This problem is G18 and it's another problem on rate of change, and what we're looking at is the distance in kilometers a missile travels in t minutes is given by that equation. So what we need to do firstly is to find the initial velocity, and that is 18.1, and your initial velocity would obviously be d prime t, and that's equal to v of t, and that is minus 2t plus 40 is equal to 0, and therefore you've got that's your, and then the initial velocity will be v of 0. V of 0 is equal to 40 kilometers per hour or minute. That is the first one. And the second part of this is we have 18.2. After how many minutes will it reach its maximum height? So when your derivative minus 2t plus 40 is equal to 0, and that gives you t is equal to 20. So it means after how many minutes? After 20 minutes the missile will reach its maximum height. Then they want to know what is the height of the missile when the velocity was 20 kilometers per hour. So it means you will have minus 2t plus 40, which is the velocity, and when it is 20 kilometers per hour. So when we solve for t is equal to 10, and it means after 10 minutes the velocity would have been 20 kilometers per hour. And then that question, what is the height of the missile? So the height of the missile is when we now take d10. So d10 means we got to substitute. You'll get minus 100 plus 400, and that gives you 300 kilometers per minute. Height was 300 kilometers, not per minute. 18.4. When the missile hits the ground again, it would have reached its target. After how many minutes did it reach its target? And so if we look at the original equation, you've got minus t squared plus 40t is equal to 0. So if you look at this, if you solve that, you get t is equal to 0, which we know about, or t is equal to 40. So after 40 minutes it would reach the ground again. Now that takes care of the calculus, and as I said before, please go through all the problems in calculus that were not done, and if you didn't understand something, you can always repeat, look at the DVD, watch the DVD again. This problem is G6, and again on calculus. The sketch is given as minus x cubed plus cx. A and B are the turning points, and I just need to put these turning points in there. A and B are turning points, and we have the root 2 and t. So, and then B is at the base here, turning point, and then we've got P at this point. So very quick, they wanted us to find the value for 6.1 of C. Now your derivative equals 0 is minus 3x squared plus C is equal to 0, and replacing x by root 2. So root 2 squared is 2 times minus 3 is minus 6, so C is equal to 6. Then that gives you the value. 6.2 now says determine n such that it will have one negative root only. Now, one negative root only, you will notice, is above that value there. So obviously we need the y value at that point, and we know that c is 6. So our y value is going to be or the t value that we've got there is 2, is minus it will be root 2 all cubed plus 6 times root 2. Now root 2 squared is 4, so you'll get minus root 2 squared is 2, so you get minus 2 root 2 plus 6 root 2, giving us 4 root 2. And then 4 root 2 is this value. Now you find that on 4 root 2 you will have a one positive root and one negative root. Above that, where now you notice that they gave us n. So n is like this axis. It is like the x-axis, and we know y equals 0 gives us these values, so we can play around with that, and then we know that n will now be greater than 4 root 2, can't be equal to. And then we've got number 6.3, which says 6.3, which says that the tangent line to h, which are parallel to AP. Now the tangent line h parallel to AP. So what it does, what it really means, that the gradients are equal. The gradient would be equal. Now we need to look at the x-intercept, because we need the point P. So if we look at the original, it's minus x cubed plus 6x is equal to 0, and then we get x, x, we can x into x minus x squared minus 6 is equal to 0, and then we know x is equal to 0 is one of the points, but which means the graph is drawn a little bit incorrectly, but that's not a serious problem. Here now we will get x is equal to minus the square root of 6 at P. X is equal to minus the square root of P. So P's coordinates are actually minus the square root of 6 and 0. So, and having got that, and we've got A, and A we noticed is root 2 and 4 root 2. So if we actually look at this problem very carefully, we've actually got we need to find the gradient. We need to find the gradient, and which is obviously the derivative as well, and equate both the gradients. And now in equating both the gradients, you'll notice that the gradient of minus 3x squared plus 6x, now the minus 3x squared plus 6x is actually the gradient. So that's the gradient of the tangent line. So the gradient of the tangent line is minus 3x squared plus 6. So now we want to equate it to this. Now we find the gradient of that line, it's 4 root 2 upon 4 root 2. If we look at that gradient of AP, that is equal to 4 root 2 upon root 2 minus minus root 6 is root 6 plus root 2. And when we actually rationalize this or simplify this, we will actually get 2 root 3 minus 2. And then we need to actually solve, and when we solve we would get minus, we're taking that on the other side, so we would end up here we've got 3x squared minus, which is minus 2 root 3, and then if we solve for x, so we will end up with x is equal to plus or minus the square root of 2 root 3 minus 8 all over minus 3. And if we go to the options, we will have that as one of the options. This problem is G10. It's still in calculus, and now we find the value of the constant p if it has a local minimum when x is equal to 2. So in other words, we need to find the derivative, and we will use this f of x as 2x squared plus 1 over px. Now your derivative of that is 4x plus 1 over p, which is equal to 0, and then we know that x is equal to 2, so 1 over p is equal to minus 8, so p is equal to minus 1 over 8. This problem is G14, and you will notice that find the area of the largest rectangle bounded by PQRS, bounded by the line y is equal to 2x at the x-axis and the line x minus 4 equal to 0. Now the line x minus 4 equal to 0, its x is equal to 4, and then we also notice that now this y is equal to 2x is actually the line, that straight line. So what we need to now do is try to maximize this area. So what we can do, we know when they said, if you look at this, it says x is equal to 4, so the coordinates here are 4, 0, so that distance is 4. So if we let this part here be x, then that part is 4 minus x. So we got that part as 4 minus x, and then if you look at the if we look at our value here, we've got where it intersects, we got x is equal to 4, and we know that y is equal to 2x. So if we substitute x equals 4 there, y is equal to 8. Now we know that this point here is 4 minus x. So if we let this value here be x, then what will happen if you substitute 4 minus x there, you will get 8 minus 2x. 8 minus 2x. So what happens really is we now can find the area. So the area in terms of x is x times 8 minus 2x, and that gives us 8x minus 2x squared. Now if you look at the problem itself, it says we want the largest possible area, and you know the coefficient of x squared is negative, so therefore it will have the largest area. So we find the derivative, which is 8 minus 4x is equal to 0, and x is equal to 2. So when x is equal to 2, we are going to get the largest area, and then the largest area we substitute in the original always, so it will be 2 times 4, which gives you 8. This problem here is G16. It is on rate of change. The data collected in a certain year, a certain time over many years, shows the number of people affected by a disease increases according to the function n of t, which is 3t squared plus 20t, where t is the number of years. The first part of the question is 16.1. Is determine the rate at which the disease will spread in the 10th year. So we're looking at the rate of change, which means your derivative n prime t is equal to 6t plus 20. Now in the 10th year, you will have that rate being 6 times 10, which is 60, plus 20, and that is the 80. So in other words, the rate at which the disease will spread is 80 in the 10th year. It will be that. 16.2, how many people will be affected when the rate at which the disease is spreading, is equal to 200. So what we're looking at is equating that to 200, and then you'll find that 6t is equal to 180, t is equal to 30. So we are now going to substitute 30 into the original to find how many people were affected altogether, and that will be 30 squared 900. 900 times 3 is 2,700, plus 20 times 30 is 600, and that gives us 3,300.